So, hello everyone, Kashav the side. So, I am back again with one of the important aspects of IT student or maybe a CS undergrad. It's a data structure and algo. So yeah, we used to do these kind of problem solving things, but today I come up with one of the interesting idea that every day I try to solve one question, pick randomly but specific, topic is specific, like two pointer sliding window or maybe stack from queues, like that. And I try to solve that live, so that I can build my logic. And if you are watching that, you can have a perspective of different human, like how I am thinking to that problem, how I am thinking to solve and approach to solve that problem, and how you can think. Because the wider spectrum we have for anyone, for anything, it's uh, the possibility to solve any kind of problem is increased, right? So that's what I think, guys. It's not your loss. uh, Instead of watching reels or any kind of stuff, you can watch this video to have some idea. So yeah, let's get started. So yeah, this is two pointer concept. Today I'm gonna start with two pointer. I have solved some 10 questions approximately, 13. So let's pick any one of the problem statement. Okay. Mm-mm. Oh, I am gonna pick some easy. Uh, I think I can go with this linked list. Uh, and I am gonna code in JavaScript, friends. Yeah. So we have something kind of this. You guys see? Yeah. So now you can see we have this. Okay, guys. We have this first node, second node. Okay, I don't have any pencil right now. Okay, no worries. Yeah. And let's just start the timer also. Okay, sorry. Stopwatch. Yeah. So here what we can see is first node is connected to second node is connected to third node, and third node is connected to fourth node. And we can see here is fourth node is again connected to the second node, right? So we can, what we have to do is here, let's just cancel this out. Yeah. So let's just read the statement. Given head, the head of a linked list, determine if the linked list has a cycle in it. So first statement is saying that we need to determine that if the linked list has cycle or not in it. There's a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer internally, and is used to denote the index of the node, and tail's next pointer is connected to. Note that POS is not passed as a parameter. Return true if there is a cycle in linked list, otherwise return false. Okay, we need to return boolean. Okay, let's go. And here is the input. We just need, we will be receiving just head. It just for example that this is a linked list 3 2 0 -4, and POS is 1. POS means on which node our linked list has a cycle. So here we have cycle, right? This. So true, We don't need to return pos and kind of thing. We just need to return true and false. Explanation is, there is a cycle in it in linked list, what the tail connect to the first node, where the tail connect to the first node, and yeah, we are calculating via zero indexing. Example 2, yeah, here it is again. 0 1, again zeroth node pay we have some kind of linked list cycle. And if the node has single node, if linked list has single node, so we cannot have a cycle, right? So yeah guys, this is kind of thing which we have. So let's just do. If you are not able to read properly, let me just increase and minimize it. So yeah, so let's just firstly now, let's just see the concept here. Here is, okay, sorry guys. Here let's suppose 10 and 20, 30, 40, right? And we can see this is again going to the loop. So if I do indexing, I is equal to 0, is equal to 1, I is equal to 3, oh, sorry, oops, guys, I is equal to 2, I is equal to 3. This is indexing, right? And if I talk about nodes, so this is first node, this is second node, this is third node, this is fourth node. Okay, guys. So this is linked list, and this whole is called a linked list. Linked list. So we need to detect whether a linked list has a cycle or not. Okay. So when I was learning some data structure concepts and in theory, I remember that let's just have a linked list again. Okay, and this 10, 20, 30, and 40. So yeah, now let me just explain what I used to read at that time. We will be, uh, going this approach. We will take one variable, let slow pointer, initialize it with head, and let fast pointer, initialize it with head also. Yeah. And what we need to do is every time we will be running a loop. Okay. We'll be running a loop on it on the linked list. And what we have to do is we will increase slow by one node every time, and we'll be increasing head by two nodes every time. And if any linked list has a cycle, then that means at any of the specific position, these two, slow pointer and fast pointer, will be meeting. Like slow equal fast, like this. They are meeting. They will be meeting. They will be Meeting. Meeting. That means that means we can say that uh, linked list has a cycle. It is I don't remember the name, but I think it's a algo, predefined algo, Floyd Warshall cycle detection algorithm. I guess I don't remember the name, but guys, you can go and cross check that. I'm also going to check and cross check. Let's just check now. Let's just check on Google. Uh, is there any algo to detect cycle in linked list as Floyd Warshall algo? It will give us some answer. Yes, there is an you can see, guys. Yes, there is an algorithm by Robert W. Floyd, maybe Warshall Floyd, used to detect cycles in linked lists, commonly known as Floyd's cycle finding algorithm or the tortoise and hare algorithm. Yeah, tortoise and algorithm. Why we are saying that? Because tortoise and tortoise and hare. If you have heard any story like that, so you can say that you can say that you can say that tortoise जो है that moves slowly and hare moves faster. And here what we are doing, we are just taking two variables, slow and fast. We're taking two pointers, slow and fast, and just moving. Slow is moving slow and fast is moving faster, right? So here we can analyze by this. And however, there's a different algorithm from the Floyd-Warshall algorithm, which is used to find the shortest paths between all pairs of nodes in a weighted graph. The linked list algorithm is generally referred to as just Floyd cycle finding algorithm to avoid confusion. Okay, sorry guys, I was having some confusion. Floyd-Warshall algorithm is something that used to have a shortest path between all pairs of nodes in weighted graph. The linked list algorithm that finds a cycle in linked list is just a Floyd cycle finding algorithm. So yeah, Floyd's cycle finding algorithm. Here, mm, yeah, Floyd cycle finding algorithm. So guys, let me just do some code also. How can we approach this? So let slow is equal to head, and let fast is equal to also head, and while mm, guys, let's just see at what what is the base case where we need to terminate our while loop, right? So slow like this, and fast like this, then slow like this, and fast like this, right guys? But I don't think it will go like this because, sorry, this and here the next pointer comes is here. Okay, okay, okay. So like this, and then slow will go like this, and fast like go like this. So I think slow is moving slowly, fast is moving faster. So what we can do is we can say uh, when run the while loop when, sorry, not here, while loop when the fast dot next dot next is not equal to null, because fast dot next is this and dot next is this, right? And if the fast is here, fast dot next is this and dot next, if there is no link cycle, it will terminate here only. Dot next is dot next is say dot next is null. Fast dot next is this and dot next is null. So that means we need to terminate here only. Okay. Yeah. And if it's terminating now, so we can say that it's terminated and there's no cycle. If it's not terminating, it is just looping in itself. That means there is a loop. So while fast stop guys, let me just, so yes guys, sorry for interruption. Yeah, so where we were, yeah, so we were here. If it's null, then terminate here. If it's not null, sorry, go to inside loop and increase slow. Firstly, check if slow is equal fast. If that's the case, return true. If that's not the case, slow is equal to slow dot next, and fast is equal to fast dot next dot next. So like the solo text fast is equal to fast dot next. And if it's coming off, after crossing the while loop, that means there's no cycle and we can return true, sorry, false. Sorry guys. Yeah. Let me just check once. Return true if there is a cycle in linked list, otherwise false. Okay. So if the cycle is, then true, otherwise false. And check also if head dot next is equal null. That means head is a single pointer. Matlab linked list has a single node. That means there is no point to go further. Return false. And also, and Head is also a null. Means if this is something that is true, return false. If I think guys we have done we have done correctly. I think let's just run. Accepted, guys, accepted. Wow, nice. I'm not believing myself. I have done it correctly. Amazing. Oops. At line number 14. What we have done wrong. I think we need to make sure that firstly we are doing this. Hmm. Output is true, but expected is false. We are breaking down at test case 17. This is our code. Let's just go to ChatGPT. And guys, we are not going to ask the answer. We're just going to ask as a mentor. Uh, Bro, this is my code. Please give me only uh, advice, like what, where I am doing mistake. Please do not give me answer. Only mistakes advice, no solution code. Here's where the thing are going off. Wrong comparison. You're comparing slow dot value, fast dot value. In cycle detection, you must never compare values. Different nodes can have the same values. False positive risk. Okay, we were doing good at that time. We can just compare slow and fast, right? As we were doing correctly. The second one is pointers start at same place. Slow and fast both start at head. If your if check can trigger before any moment. Okay, guys. What we are doing that we are just increasing and we're not increasing this. We are not performing this operation. Firstly, we need to perform the operation because initially what we are doing, we are just initializing slow and fast with head, and here we are checking slow if slow is equal fast. Obviously, it will be equal fast, guys. Loop condition is unsafe while fast dot next is not equal to null can throw an error. You are accessing next without checking fast and fast.next. Okay. So I think before checking it, we need to check fast is not equal to null and fast dot next is not equal to null, because firstly check fast is not equal to null, then check fast dot next, and then check fast dot next. Hmm. Hmm. I think, guys, I'm going in the right direction. Let's just submit it. Line number 23. Cannot read properties of null. So guys, I understood the problem. Here we are assigning fast.next.next in fast, but there is no fast.next.next, right? It's null already. That's what I was doing some mistake. Fortunately, why are you going in this direction? And oops. Guys, I've done some mistakes. Yeah, yes. Output is false and return is true. Expected is true, and we are returning false. Hmm. Hmm. So 3204, 3 is a 2, and 3 is a 0. Fast. Okay. And while we'll check, fast is not null, fast dot next is not null, and fast dot next is not null. So slow will go here, and fast will go here to here. Okay, 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 okay. Sorry, guys. Hmm. Time taken 31 minutes and 15 seconds. So this is the code, guys. I have done memory beats 68.22% and runtime 8.69%. Damn, that's very low, but still, guys, we have done it in quite effective manner. Let's just stop it. So yeah, guys, this is what we have done. We have detected a linked list cycle, and yeah, thank you so much, guys, for bearing with me. And we'll be meeting again soon in some other videos. Guys, I think I should paste the code in comment section. I guess, but I don't think, because why to spoil your logic building? Why? Just try your best thing. Like try with your brain, not with my brain. My video was that to expand your knowledge, like expand your perspective, like how in different ways you can think of, right? So yeah, thank you so much, guys. We'll be meeting again. Thank you.